Okay, this is MISLE, which stands for matrix inverse solutions to linear equations. So it's the relationship between solving a linear equation and the inverse of a matrix. So first, let's talk about the inverse of a matrix. The symbol for an inverse of a matrix is A minus 1, and the theory was talked about in the section. Basically, a multiplicative inverse is a number that multiplies by another number and turns it into 1. Well, for matrices, that multiplicative inverse is the inverse matrix, and it basically turns any matrix into the identity matrix, which, remember, is a square matrix that has ones along the diagonal and zeros everywhere else. So this is what we're looking for. If this is A, what's A to the minus 1? What's the matrix that times this one will always produce the inverse matrix? Now, the tricky thing is not all matrices have an inverse, but we'll find out right away on this one. There's a special technique for finding the inverse of a 2x2 that's really easy to apply. It'll be harder as the square matrix gets larger and larger and larger, but we don't really need to worry about that for this problem because we can use the 2x2 technique. So here's what that technique is. If I want the inverse of any matrix, then basically what I want to do is I want to take 1 over the cross product. This is basically elements A, B, C, and D. So it's AD minus BC. And then I want to multiply that by a rearranged version of this matrix. First, A and D change spots. So D is here and A is here. And then B and C both become the negative of their originals. So negative B and negative C. So if I take this ratio and multiply it by this rearranged matrix, that will be the inverse. Now, when does a 2x2 not have an inverse? It does not have an inverse if the cross product turns out to be 0, because clearly I can't multiply it by a fraction that has 0 in the denominator. That would be undefined. I can always do this rearrangement, but this is where the problem falls. Okay, so let's find it for this particular one. Should be pretty easy. First, AD minus BC. So that's 14 minus 15. So it's 1 over 14 minus 15. And then the rearranged matrix is going to be the 2 and the 7 switch spots. So this is 2 and 7. And the 3 and the 5 both become negative. Negative 3, negative 5. Okay, this is just 1 over negative 1. So that's just a negative in front of the matrix. So that just changes all the signs. So this is negative 2, 3, 5, and negative 7. And what we're claiming is that this then is the inverse of the original matrix. Well, let's check. If it is the inverse of the original matrix, then the product of this and this should give me the identity matrix. Let's see. So our original matrix is 7, 3, 5, 2. And if I multiply that by its own inverse, which is negative 2, 3, 5, negative 7, I'm supposed to get the identity matrix. Let's see what we get. 7, 3 times negative 2, 5. That's negative 14 plus 15. That's 1. 7, 3 times 3, negative 7. That's going to be 21 minus 21. That's 0. 5, 2 times negative 5, 2 is negative 10 plus 10. That's 0. And 5, 2 times 3, negative 7 is going to be 15 minus 14, and that's 1. So there it is. It is indeed the identity matrix, and that verifies that this is the inverse of A.